Okay, if I graph on 240 degrees, I know that 240 degrees, if I took 180 degrees away from that, that gives me 60 degrees. So really my angle is 60 degrees beyond the 180. So I've really just calculated my related acute angle here. So 240 does lie between 0 and 360. So my principal angle is just that 240 degree angle. Okay, it almost always is the angle that's given unless it doesn't fall between 0 and 360. Then we have to do a little bit of work with it, but otherwise we're good. Okay, our related acute angle, as I said, I took 240 and I subtracted 180 degrees from it to see what was there, and that gave me 60 degrees. So my related acute angle is just this angle in here. That's my 60-degree angle. Just rewrite that in red. If I want coterminal angles, I can just take that 240 and subtract 360, and I get negative 120 degrees there. If I take 240 and I add 360 to it, I get 600 degrees there. All right, 330 degrees. If I take 360 and subtract 330, I get 30 degrees. So my related acute angle is this 30-degree angle in here, but my 330 is my principal angle going all the way around to that terminal arm that I drew in there. So my principal angle is the 330 degrees. The related acute angle, the raw, is 30 degrees. And if I take 330 and subtract 360 from it, I just realized I mistakenly marked another question with the wrong Roman numeral. Sorry, distracted. 330 degrees minus 360 would give me negative 30 degrees. If I take 330 and I add 360 to it, I get 690 degrees, and that's sticking within that domain that is specified up above. Now, negative 225 degrees, I'm going in the clockwise direction. I'm going to go beyond 180. So if I take 225 and subtract 180, I'm just going to see how far beyond. I'm 45 degrees beyond the 180 degree mark. So 225 goes around here. So that's negative 225 degrees. My related acute angle helped me to draw it. That's that 45-degree angle in here. It's the angle that terminal arm makes with the x-axis. So we've got our principal angle we've got to figure out yet. So the negative 225, that does not fit in between 0 and 360. So I'm going to take negative 225 and I'm going to add 360 to it. 225, add 360. I don't need to do that. That's going to be 135 degrees. So my principal angle is my 135 degrees here. My related acute angle, we already figured that out, is 45 degrees. And coterminal angles, well, of course, 135 is coterminal with the negative 225. If I tried subtracting another negative 360 from negative 225, I'm going to be beyond negative 360, which is part of my domain there. So I'm just going to add two groups of 360 to our negative 225, and I get as a second coterminal angle 495 degrees. All right, now let's look at this last example here. We want to determine the measure of angle theta in standard position to the nearest degree if its terminal arm passes through the point 1, 5. So first thing I'm going to do is sketch that so I can organize my information. I'm in that first quadrant, so remember that the Cartesian plane is broken into the 4 pieces and they're called quadrants. I'm going 1 to the right and then I'm going up 5. So point P is somewhere around here. So let's say this is 5 and this is at 1. So my terminal arm, let me grab a different color here. My terminal arm is going to pass through there and look something like that. And if I had a ruler and could use a ruler on this iPad, I would. But I can't, so I won't. Now, we want the measure of angle theta. So that's my angle right here. It's my related acute angle as well as my principal angle. It's the angle in standard position there. I'm just going to redraw that little arc. It's that angle right in there. So what I'm going to do is I'm going to take and draw a right angle triangle. Okay, so I've got my right angle triangle here forming that angle. I can use SOHCAHTOA with my right angle. I know that the side opposite my theta, my principal angle, which is theta in here, the side opposite is this side, which is 5 units long. It's equivalent to the y-coordinate of my point. So this is opposite. And I also know that this side here, that one is my adjacent, and it's 1 unit long. That's my adjacent, and it's 1 unit long. Okay, so if I know opposite and I know adjacent, I know that I can use tan of theta would equal my opposite over my adjacent. And I can solve that for theta by doing the inverse function of tan on that value, that's supposed to be -1, on that value of 5 divided by 1, which is just really 5. So if I do my second function on there, I get theta being approximately equal to the nearest degree, approximately equal to 79 degrees there, which makes sense. It is a fairly steep angle there compared to some other angles. All right, now I also want to state the 6 trig ratios of the angle. So I've already stated one of them. The tan of theta is equal to 5 over 1. The sine of theta is opposite over hypotenuse. Now opposite is 5, but we don't know hypotenuse. But we know we can get hypotenuse because it's a right angle triangle. We've got Pythagorean theorem. I'm going to say that my hypotenuse squared would equal my squares of my other two sides added together. So 5 squared plus 1 squared would be 25 plus 1 is 26. So my hypotenuse as an exact value would be the square root of 26. So then when I state my sine ratio, it's going to be 5 divided by the square root of 26. The cosine of angle theta would be the adjacent, which is 1, over the hypotenuse, square root of 26. And my tan I already have stated. My other 3 ratios, the reciprocal of sine is cosecant of theta, which would equal the square root of 26 over 5. I just flipped over the sine ratio. Cosine goes with secant. Secant of theta is its reciprocal, the reciprocal of cos, which is 26 over 1, or just 26. And the cotangent, last but not least, will be the reciprocal of our tan. Tan was 5 over 1, cotangent would be 1/5. All right, so there we have it. Make sure you try the practice questions and ask for help as needed.